And now we set the problem in the fluent, and I will specify these material properties and these boundary conditions, and these are solver settings, and also I will create these three points, and I will monitor the convergence of the temperature or maybe velocity at these locations. These locations are just after this mixing of the two fluids, hot and cold. And you can see here the convergence plot for the point 1, which is the vertex average temperature values, point 2, point 3, and also we are accessing the convergence of the continuity, momentum, energy, and the K epsilon for turbulence model. And based on these results, we can confirm that the solution has been converged to some reasonable value. So there are two things. One is that the scale radius, they should be the straight lines, and typically they should be below the 10 power minus 1 or maybe minus 4. And secondly, the local parameters at some point locations, they should also converge to some fixed value. Now let's start in the fluent. And for that I will create the fluent container here. Okay, so from here we get the fluent and drop it on the mesh file. And before opening the fluent setup, right click on the mesh cell, which is the B3, and click on the update. And now double click on the setup, which is cell number C2, and this will open the fluent dialog box. And from here I will choose the parallel, and since I have the only 4 cores, I will use maximum 4 cores here. And for this small problem with the number of nodes not more than the 1,12,000 for the fine mesh, and maybe up to 3 lakhs for the very fine mesh, so I think using of 4 cores may be a overkill. But anyhow, I'm using the 4 cores here, and the few settings I will be making is that I will be using the K epsilon reliable turbulence model. So before that, I would be checking the scaling of the mesh. So you can scale from here, and before that I will be changing the units to for length to the inches. And if you recall that the units of this geometry, they were in the inches. And let me show you this case with in the sketch. So you can see that in the x direction, if I'm making geometry along the flow direction and the x direction, so you can see that we have the length of geometry in the x direction 32 plus the half of this value, which might be equal to 16. So this is up to the here 16 here, and 16 more for diameter. So 16 plus 32, 64. So if we get the 64 inches in the x direction, so 0 minimum value and maximum value 64, it confirms that our mesh units are correct, and there is no need to scale the mesh to the required units here. So close this box here, and you can also click on the report quality. So here we are getting the minimum orthogonal quality of the 0.16, and the maximum aspect ratio as the 24. And if you want, you can also enhance the quality description for the mesh to some other matrices as well. And for that, I will type the mesh here and then click on the enter key. This will give you some options, and from here I will be checking this option, which is the check verbosity. You can type this full command, or you can type only the first letter for these two words. And 0 is when we have the no detailed progress output, so only we have the basic information here. So let's say if I put the value 1 here and click on report quality, so still we have the almost same, but this time it's almost same. So let's say again I put this value to 2, and this time click on the report quality. So you can see that we have some more information here. So we have the minimum oscillation quality, which is same here, and also we have the maximum cell skewness index, which is a 0.74, and here we have the maximum cell EQ volume skewness, which is we have seen for the Ansys meshing, and this value was 0.83, and almost same value we are getting from Ansys meshing, which is 0.81, and here it is quoting as a 0.838, and also the maximum aspect ratio is 24. And if you take a look on this description, so I think I can check it. So might be you can double click on the mesh cell here, and check the mesh quality, these parameters in the Ansys meshing as well. And if you take a look on the Ansys meshing aspect ratio, the maximum value is 17.078, and while in the Fluent the value is 24.3. So there's slight difference between the definition of the aspect ratio. The value should be less than 100 for the simple cases, and you can go up to 1000 in the boundary layer for the single precision solver, and up to 10,000 for the double precision solver only in the boundary layer. But try to keep the value less than 10 when you are at the interface or you are in the very far field. And to display the mesh, you can only display the faces in this way. And if you want to hide some faces, for example the inlet large, or you want to hide the symmetry plane, for example, this can be done. And if you want to only display the edges or the nodes here, and you can also change the color to, let's say, to by color by ID, and this will give you the different colors for the different geometry parts. Let's say I display all the parts here, and if you want to save the picture files or image files, so you can go to file menu, and from here click on the save picture, and there are different options. EPS is used for the mostly for latest documents, and for Word documents you can use a JPG or PNG. Most commonly used they are the JPG and the PNG, and if you want you can change the resolution of the this picture file. So let's say if I make the picture file as a resolution of the 1080p, and for that the width should be equal to the 1920, and height should be the 1080, and the orientation is a landscape, and if you want you can change also, and the background is a white, and you can check the preview first. So I can let's say zoom the geometry and to get the full view. So this seems fine to me, and if you want you can also have the default background. So let's say I again go back to this white background and save the picture file. So I can save it, let's say, in the D folder, and the mesh file name, this file name for the picture is the sys.jpg. You can change the file, let's say, to the mesh file, mesh.jpg, and save it. And then from the D drive you can open the file here, and this file is over here. Double click on the file to open the file. This is how this file will look like in the JPG file, and this can be used for the when you want to make the report or maybe presentation or maybe thesis report. So this is all about how you can open the file in the Fluent and apply some operations, some basic processing on the mesh file in the Ansys Fluent. And right now we are using the Ansys Fluent 19.5 version. which is also known as the 2019 release.